Hi, Gabrielle. And it is Thursday, and we're going over the homework. So, chain rule. All right. So, questions. Questions on chain rule. Okay, so I heard 17. Okay, so let's look at 17. I think 17 was the very first one, and it was very similar to the example we did in class. Okay, so I will talk to you. So Gabby, if you have a question about it, talk to me during class, okay? The 17 was similar to the last example. So look at that, okay? All right, so 40. Can anybody else before 40? I heard something over here, 20. No? Okay, so let's look at 40. Oh yeah, 40. This looks fun. All right. So we are going over unit 3.4, correct? Yes. Okay, so it looks like this. So this is a pretty crazy looking problem, all right? So before we start to do it, let's just think about what is this doing? What is it saying to do? So, for example, if I put in, let's say, pi over 2, okay, what I would be doing is I would start right here, right? I would do sine it pi over 2. What is sine it pi over 2? Okay, people should know this, so if you don't, you need to get this down. Sine it pi over 2 is 1, okay? It is 1. You should be able to answer that pretty quickly, okay? So sine it pi over 2 is 1. So that's what I would first do. So this is 1, and then I would do sine it 1. So now I'd have to actually pull out my calculator, okay, because 1 is not on our unit circle. You guys don't have to do this right now, okay? I'm just showing you what I'd have to do, okay? So then I would do, okay, so then I would have sine at 1, which looks to be 0.841, okay? So then this is now 0.841, and then I would do sine at 0.841. Okay, and then I'd finally have my answer, all right? So this isn't like a sine times sine. I wouldn't want to write this as, say, sine cubed, because this isn't sine cubed, okay? We would be taking sine x and then taking the sine of that and then taking the sine of that, all right? So people kind of understanding what's happening. So let's first start with, it looks like the most outer function, in this case, is this sign, correct? Okay, so I'm going to go ahead and cover this up. I don't have even a U big enough to cover it up, but make one that's a little bigger. Okay, I'm going to cover that up. So I'm going to think of it as sine happy face variable. Okay. So I'm going to start with chain rule. So I'm going to take the derivative of this outer function. I'm going to leave that inner function alone. Now that inner function we know is also a composite function, which is what makes this problem interesting. So let's start. So derivative of sine, cosine. And then that all stays the same. And this is a problem I'm definitely going to not try to do all of this in one step, okay? I'm going to now write, now I got to take the derivative of this inner function right here. Okay, so now I'm taking the derivative of that. So I'm going to have the derivative of sine x. Okay. All right, we are looking at problem 40. So, all right, so let's continue with that. So now I'm going to look at this. Well, what's the outer function now? Sine again, correct? Okay, so it's sine again. So I'm going to go ahead and write, I got cosine of, I left this alone, times, and now again I'm going to go ahead and cover that up. I could use u now because it's not so big. Okay, so now I'm taking the derivative of this. So again, derivative of sine, cosine. Leave that inner function alone. Times the derivative of this inner function. Well, that's pretty easy now. Derivative of sine x is cosine x. Okay, so that is my problem. How do I kind of simplify it a little bit? Okay, well, I could think this is just going to be cosine x. Okay, so kind of going back to that pi over 2. If I put pi over 2 in, this would just be cosine of pi over 2, which would be 0. Okay, but here I'd have to do sine at pi over 2, which is 1, and then take cosine at 1. Okay, so, and then of course this top one I'd do what we did at the beginning. So I'm just going to go ahead and pull the cosine x in front. So cosine x times, and then I think I'll put brackets around that first one, sine of sine x times, and I think I'll just put brackets around this other one here, which is cosine of sine x. Okay, but leaving it like this would have also been okay. All right. How many people got that correct? All right, good, Keisha. All right, good, Cam. Okay, other people? Okay, just takes a little bit of practice. All right, other problems. Did you guys have 44? Let's look at 44. Okay, so this is even a little bit hard to see. So it's 2 to the, is that 3x or is that 3 to the x? Oh. Okay, so 2 to the 3 to the x squared. That's what I thought. Okay, whew, all right. Okay, so this problem, I'm looking at, okay. It's definitely a 2 to the, hold on, I want to double check the note, I want to double check this in the actual book, because if we go ahead and call this u right here, we actually haven't talked about the derivative of this yet. Okay, so I want to just check and make sure that it's not supposed to be 3x being squared. So we'll come back to this problem. We'll come back to this problem. Okay, so leave it out for a moment. Okay, so one other one, 23. And then I want us to get started, because okay, so looking at this problem, what is our outer function? How about Alfredo?
Outer is e to the u.
Okay, so let's cover that up. In fact, my u still isn't quite big enough. I'll go to the, okay. All right. So let's take the derivative of e to the happy face. So the derivative of e to the happy face, Cameron? That's right. So e to the, and the happy face was x cosine x. But now I have to times it by the derivative of this inner function. All right, so I'm going to again go ahead and write that out. I'm going to put, I got to do d dx of x cosine x. Because I can't really do this in just one step. Okay, so the reason why I use this notation, the reason why sometimes I don't use it, is because if I'm just taking the derivative, if that was just cosine x, it'd be really easy just to write negative sine x, correct? But looking at this, I can't just readily see what the derivative is. In fact, I'm going to have to use product rule, right? Okay, I'm going to have to use product rule. So when that's the situation, that's when I take this extra time to write this down. Okay, I can't just readily see what the next derivative is. Now I'm going to go ahead and do that. Times, and I'm going to put a bracket here because I'm going to use product rule, and I know that there's a sum involved with product rule. Okay, so I want to make sure I have it in a grouping symbol. I know this might look really redundant to have a times with the bracket. That's you can, or you don't have to, but I have it. All right, so let's take the derivative. This is my f, this is my g. How about Elizabeth? Go for it. Okay, so we're taking the, so we got to use product rule here. Good, so bx times negative sine x. And to save a little bit in time, I'm just going to go ahead and put the negative in front, sine x, okay? If you did use grouping symbols and you put times negative sine x, that's fine, but just make sure you don't make that mistake of thinking it's minus sine x. Okay, plus, so now my g stays the same. Good, times 1, which I'll just leave as cosine x. Okay. So now at this point, I just want to look, I've already got this in a factored form, which is nice. But are there any common factors in here that I could also factor out? No. Okay. So this is it. I'm done. Okay. All right. Okay. So what I'd like is, because we got about a little over 20 minutes, okay, minimum schedule day. I would like people, we're going to work on some group work, all right, and did I even write that down up there? No, I didn't. I will, okay. So let me stop this.